Now for 12.3, we're going to be talking about the exponential functions. So we're going to have functions with an exponent. So we're going to say that a to the x. Now, two restrictions. One of them, that the value of a, that numbered, must be bigger than 0. Right? If it's not more than 0, let's think of negative 2 to the 1/2. That gives me the square root of negative 2. But I'm calling this all real numbers. I cannot use imaginary numbers. This with real numbers, I cannot get the square root of a negative. So that's why we're saying a, the value of a must be bigger than 0. And then also another thing is the value of a cannot be 1. Otherwise, 1 to the x, 1 to anything, 1 times 1 times 1 times 1, I can multiply 1 many times. It always gives me a 1. And yeah, that we cannot do that. So we're going to call this exponential function f of x is equal to a to the x. A is any number. But remember, my a must be a positive number and cannot be 1. Those are the two restrictions. Now let's work with them. We're going to learn how to graph these. So I'm just going to think of a few values of x. I can create a chart. I can create a chart of x's and y's. I can come out with any values of x that I want. If you guys want to, I'll think of 0, positive 1, positive 2, positive 3. Right, we can keep on increasing. Now, for my y value, I'm thinking 2 to the 0. Right, 2 to the 0, anything to the 0 powered is 1. 1, now for my y value when x equals 1, I'm thinking 2 to the 1. If you notice, I'm looking at the function 2 to the x. I'm replacing x with the value that I think of. 2 to the 1 is 2. Now here I'm going to think 2 to the 2. Well, 2 to the 2 is 4. 2 to the second power. 2 to the third is 8. So if you notice, I have the points 0, 1, 1, 2, 2, 4, 3, 8. And I can go on and on and on. I can come up with more points. Now, I can easily plot these points. I'm going to say I graph them. I plot it in my case, and this is what I got. Notice I have the point here 0, 1, 1, 2, 2, 4, 3, 8. Right? I have the points that I came out with. So that gives me a good idea. Now, what if I have something like 1/2? Now, the interesting part here, I'm going to show you guys something really, really cool. 1/2 to the negative, I'm going to be thinking, actually, let me just do this. Let me think of a table of x and y values, but in this case, I'm going to think of negative values of x. Well, I can always use 0, that's not going to affect, but on my x, any other values, let me choose negative 1, negative 2, negative 3. The reason why, because the negative exponent, it is going to undo my fraction. For my y value, if x equals 1, I'm looking at 1/2 to the x, 1/2 to the 0, right? 1/2 to the 0, since my power is 0, my exponent, I get a 1. Now, 1/2 to the negative 1 is the same thing as 2 to the 1. Notice how my negative exponent, if I switch it to positive, it undoes my fraction. And why? Because it does the reciprocal. The reciprocal of 1/2 is 2 over 1. So if I had a function and I had a 1/3 to the negative, that my negative makes it a 3. The negative undoes my fraction. So 1/2 to the negative 1, I'm looking at that as 2 to the 1. That's 2. Now 1/2 to the negative 2, I'm looking at that as 2 to the second power, which is better known as 4. Once again, my negative undoes my fraction because it does the reciprocal, right? The reciprocal of 1/2 is 2 over 1. not a fraction anymore. Now 1/2 to the -3, I'm thinking of this as 2 to the third, so I get 8. So notice I have the points 0, 1, -1, 2, -2 forward, and I have the point -3, 8. I can plot them in, and I get a graph like that. Right? I get my point, and I get a graph like that. Now, a couple of things I want us to think of, because these graphs were very, very similar. When my a value, because remember my a is this one, when my a value was more than 1, look at my function. It looks like it's going up. Because remember, we have two restrictions. A must be bigger than 0. A cannot be 1. But if my a is more than 1, my function will always go up. If my a is less than 1, it is still more than 0, but it is less than 1, look, my function is going down. So now in your case, your a value is more than 1. Now, quickly, do you think it's going up or it's going down? Like, do you have something like this? Or do you have something like this? It is going up. Now, looking at example 2, my a value is less than 1. It looks like that. I want us to remember two things. If my a is more than 1, my graph is going up. If my a is less than 1, it is going down. Now, another thing I want us to see. Look on the y-axis. Look at the point that I have in this case. I have the point 0, 1. Look at the other example that I did. Let's take a look at the y-axis. I have the point 0, 1. Now look at the graphs that I just had you guys work on. Look at the y-axis. I have the point 0, 1. And then in this other example, I have the point 0, 1. So now let's see what the book says. The graph function contains the point 0, 1, which is the y-intercept. It will always have the point 0, 1, and when it's in the form of a to the x. The function is a 1-to-1. If my a is more than 1, the graph rises from left to right. The graph goes up. If my a is still positive, so it's more than 0, but less than 1, so a number between 0 and 1, then the graph goes down. Now, if you notice on all my cases, the graph was approaching the x-axis. It never touched it, but it was approaching it. Keep that in mind for the future math classes. We're going to call that an asymptote. Right? It is approaching a line, just quite never touches it. That's what we call an asymptote. Now, my domain, going back to my graphs here, my domain, how far left does it go? My domain is going to go forever to the left. So it's a negative infinity on both cases. On my first example, it's going to the left. We can see really quick. Now, on my second example, it's going to the left at a very low rate. It's going very, very slow. But if we let it go forever, it keeps on going to the left forever. Now, how far right does it go? Always goes to positive infinity in these cases. It goes to the right forever. Now, for a range, how far down does it go? It gets to 0. Notice I'm putting a parenthesis on 0 because it never quite reaches it. How high does it go? Infinity. So the range is from 0 to infinity. So remember, our domain is from negative infinity to infinity. The range is from 0 to infinity. So those are the graphs of these functions. Now we can also look at this example. How can I work this out? Let's come out with a table. Let's think of a table of x and y values. I'm just gonna think of some values of x. Let me think of 0. Let me think of 1, 2, 3. Right, just some values of x. So if I have that x is equal to 0, right, 2x minus 4, I know x equals 0, so that's 2 times 0 minus 4. That's negative 4. So I have this as 3 to the negative 4, which is 1 over 81. Oh, wow. Okay, that's a very low number. Now, what if x equals 1? I'm looking at the exponent. 2 times 1 minus 4. Isn't that negative 2? So I have this as 3 to the negative 2. I know 3 to the 2 is 9, but 3 to the negative 2 is 1 over 9. Okay, what if x equals 2? I'm looking at the exponent as 2 times 2 minus 4. Right, 2 times 2 is 4, minus 4 is 0. So I'm looking at that as 3 to the 0, which is just 1. Now, what if x equals 3? I'm looking at the exponent as 2 times 3 minus 4, which is just 2. So that's 3 to the second, which is just 9. Half points, I can graph them. So matter of fact, I'm just going to graph them. I'm going to get this. Now, one thing, if I had the function f of x is equal to 3 to the x, you guys would have said, okay, yeah, that will cross, my 3 to the x will cross at the point 0, 1. And it will go up, right? We will be expecting, let me do this in red actually. Yeah, the way I had it. You guys will be expecting something like that, the 3 to the x. Now, 3 to the 2x minus 4 definitely does not cross at the point 0, 1. It's just that it got shifted to the right. It got shifted to the right, and it just goes faster. And why did it get shifted to the right? Because of that. That's why it got shifted to the right. I can see this. If I wanted to factor this, I see this as 2, because I factor out 2 out, x minus 2. So I can see it got shifted to the right 2 spaces. And like I said, it just goes faster. It just increases at a faster rate. All right, so now we're going to use exponents because I want us to learn how to solve for variables. Now we're going to say, as long as the value of a is more than 0 and not equal to 1, if I have a to the x equals a to the y, so I have the same base, both to the different exponents, I'm going to say the exponents must equal each other. As long as I have the same base. So looking at this, if 27, I could write 27 as 9 to the something. I will just let 27 equal that, and boom, let x equal my exponent, and we're done. However, I can't, right? Because 27, I cannot think of 9 to the something. I know 9 to the 1 is 9, but 9 to the 2 is 81. So it's like between 1 and 2, but I'm not just going to guess. Instead, what I'm going to do, because I must have the same base, I'm thinking 27. How can I possibly write 27 as an exponent? I know 27 is 3 to the third. Then I'm thinking, my 9, my other base, can I write it as 3 to the something as well? Because I want to use the same base. And I'm like, yeah, I can do that as 3 to the second. So my 9, I'm going to write everything in base of 3. So my 9, I'm going to write that as 3 to the second. That's just my 9, 3 to the second. I'm going to put the x on the outside equals 3 to the third. All I wanted was the same base. I know when I have parentheses, I must multiply my two exponents. So I have that 3 what's going on? So I have that 3 to the 2x. It's equal to 3 to the third. Now you notice how I have the same base? I'm going to let my exponents equal each other. So from here, I'm just going to write 2x equals 3. Once I have on both sides of the equal sign written as an exponent and using the same base, I'm just going to let the exponents equal each other. 2x equals 3. Let me divide both sides by 2. X equals 3/2. All right, you guys like it as a decimal? Then just call it 1.5. Now you try these at home. Now 125 you cannot do as 25 to the something. Just I'm going to give you a hint. 25 you can write this as 5 to the third. 32 you can write this as 2 to the 5. Okay, those are just hints. You guys should be able to try these at home, and that's exactly what you guys are going to get. Now let's try this one. I'm going to solve this one out. 4 to the 3x. Because I'm looking at my numbers. 4 and 16. I'm looking at my bases. Can I write them with the same base? I know 16 is 4 squared. So I'm going to write this as 4 to the 3x minus 1. And then 4 to the second to the x plus 2. I just want to have the same base. So I have 4 to the 3x minus 1 equals 4 to the 2x plus 4. Remember, you must multiply it. So that's how I got 2x plus 4. Now that I have the same base, I'm just going to let my exponents equal each other. So I'm just going to say 3x minus 1. God, I love technology sometimes. 3x minus 1 equals 2x plus 4. Once you have the same base, just let the exponents equal each other. All right, so let me subtract 2x on each side. My minus 1, I'm going to add it as a plus 1 on the other side. Switch the signs. So I get that 1x is equal to 5. So I'm just going to say my answer is 5. Now let's take a look at question number B. One thing I want us to remember, 6 to the third is 216. Okay, so now my fraction here is 1 over 216. I know 6 to the third is 216. So 6 to the negative third. Remember a couple of slides we talked about negative exponents. What do negative exponents do? They undo fractions. At the same time, why? Because they do the reciprocal. So 6 to the negative 3, I'm just going to do that as 1 over 216. Right? Negative exponents do reciprocals. That's how I got rid of fractions sometimes. So now here, what do I have for example on question B? I have 6 to the x is equal to 6 to the negative 3. Can I just say x equals negative 3? But on your homework, you guys are going to say your solution is negative 3. Right. As soon as you have everything written in the same base, just let the exponents equal each other. Now, 2 to the third, 2 over 3 to the second power. Doesn't that give me 4 over 9? I know 2 over 3 to the second power, because 2 squares 4, 3 squares 9. I know 2 to the third to the second power gives me 4 over 9. Kind of looks what I have. It's just that my fraction is reciprocal. So can I just say 2 over 3 to the negative 2 is equal to 9 over 4? Remember, what do negative exponents do? They do reciprocals. So I'm just going to say here, I have 2 over 3 to the x is equal to 2 over 3 to the negative 2. That means that x must be equal to negative 2. Notice I have the same base. So let the exponents equal each other. Now you guys try these at home. And that's what you guys should get.